Hello, we are CR-DeLorean team and welcome to our technical demonstration video.
Hello, I'm Amner.
Hello, I'm Eduardo.
Hello, I'm Vanessa. Hello, I'm Karina.
Hello, I'm Mia.
Our 4 technical features are the following. Feature number 1, mechanical innovation. Since October, our team aims to optimize mechanics inspired by the DeLorean's flight, starting with simple machines and advancing into flight simulating technologies. We developed a PVC tube pulley system with 3 pistons to simulate flight. This showcases our dedication to blending advanced technologies with unconventional ideas. Feature number 2, automated interaction. We aim to highlight robots' automation and interaction capabilities. We chose this feature to emphasize the successful RFID detection in the clock tower triggered by the Stormbolt's release. This integration shows our commitment to precise robotic operations. Feature number 3, trained recognition. This performance emphasizes the critical role of sensors and cameras. This feature underscores their significance and the complexity inherent in their use. For example, the driving simulator bot detecting QR codes with an OpenMV camera, the IOD camera accurately recognizing docked features, and the Husky lens identifying registered faces. Feature number 4, interlinked robots. Our performance aims to synchronize robots' actions with our storyline, which is why we selected this feature. We use 3 types of communication: serial for wired connections within a robot's Arduinos and cameras, Bluetooth for wireless point-to-point signals, and XB to create a point-to-multipoint among all robots' Arduinos and cameras. Now let's introduce our 6 robots. The Stormbolt is a zipline linking the largest storm cloud to the clock tower bot. It includes a release mechanism triggered by an XB signal, secured with the 3D printed piece. A servo motor powered by a 5-volt supply and housed in another 3D printed part controls the release. On the back we have the electronics, a 122 tip to control the Neon Flex strip, Arduino Uno, 5-volt regulator, and switch. The storm clouds have wooden bases supporting tall T-shaped PVC structures, controlled by an Arduino Uno and the lighting PCB. Activation at their height posed a challenge. We positioned a 12-volt LiPo battery and switch at the base, with a cable running through the PVC tube into the cloud's interior. Each cloud is stabilized by a Lego hand-like structure connecting the cloud to the clock tower bot. The clock tower bot is a PVC structure with a canvas displaying 6 windows, each with 5 LED strips, and connected to 2 lighting PCBs, powered by 12-volt LiPo batteries. A Neon Flex strip illuminates the clock, whose movement is powered by an L298 driver connected to a VEX motor. The tower features an RFID sensor for activation when the Stormbolt descends. The Hill Valley welcome sign has a DC motor with an encoder that provides data for the Arduino Mega, powered by a 7-volt battery and an L298 driver turns the sign. The front displays logos with Neon Flex LED strips and 12-volt lighting PCBs, controlled by an Arduino Uno. On the back, 2 RGB Adafruit panels show sequences. All Arduinos use 7-volt LiPo batteries with switches. The driving simulator bot is a cardboard and PVC structure that includes a steering wheel and lever driven by jumbo servos via an Adafruit controller. It simulates Marty flying the DeLorean with LEDs on the lever, steering wheel, and sides. An OpenMV camera in Python detects QR codes controlling the steering wheel and lever via the serial terminal. Bluetooth controls the DeLorean's pistons, and XB manages the upper part of the car. The DeLorean time machine has 3 levels: base, mid, and top. The base includes a wooden board with 4 DC power motors and IBT2 drivers controlled by 2 Arduino Mega units. Movement is guided by an OAK-D camera in PyCharm using Depth AI and CV2 for face tracking. The OAK-D camera detects depth and sends coordinates to the Arduino, which controls the motor and tracks faces. The midsection has 3 identical pistons, each a PVC tube enclosing a smaller one. A cable runs through a top pulley on the larger tube to a motor-driven spool, ascending the PVC. The pistons use 3D printed bases for stability with ball joints on smaller PVC for smoother movement. Power wheel motors are controlled by IBT2 drivers via Arduino, receiving Bluetooth commands from an OpenMV camera on the driving simulator bot for QR-directed movements. The upper part, like the DeLorean, includes headlight illumination, doors opening, and wheel movement. Built from foam board, duct tape, and wood, it has servo motors with 7-volt battery, jumbo servos with a 12-volt battery, LEDs and adjustable LED strips controlled with a 12-volt battery through a custom PCB and an Arduino. Due to the weight and piston instability, we're required to rebuild the top with a lightweight yet strong structure for piston movement integrity. Some essential aspects of our performance was the use of 3D printing and PCB design. 3D printing was crucial for our performance, meeting specific robot needs and with parts hard to source or make in other materials. PLA's rigidity suited our requirements well. AutoCAD Fusion 360 enabled us to create over 50 unique pieces. We developed 3 PCBs to streamline connections and enhance efficiency. Using EasyEDA, the first PCB simplified connections for the DeLorean time machine, despite now being obsolete. The second, a lighting PCB, originally a homemade prototype that was later professionally manufactured through PCBWay to illuminate all our robots. The third PCB, handmade and soldered by us, ensured secure connections for the Hill Valley sign.